Nothing like that today, but welcome once again to Forecast Lab. Hopefully we're back on track here. As you probably saw, I accidentally posted the Monday video yesterday. So hopefully we're not going to make that same mistake again this time. Anyway, let's look at the weather around the rest of the country. Well, with this being October, it's very important to look out in the Atlantic, and it looks quiet. 10% chance of cyclone formation in the Windward Islands. So this week, we're unlikely to have any hazards coming up from the Caribbean, the Gulf, or the Western Atlantic. Well, this time of year, I definitely like looking at the precipitable water because we should see the levels up pretty high in the southern U.S., but that's definitely not the case this week. Now, also, I do use the GFS output. I think these models have gotten very accurate with the objective analysis schemes. We're quite a long ways from where we were 20 years ago. So I think these are actually serving very well as a first guess. And then as I go through the data, go through the analysis process, I can kind of reconcile things, and I should see at that point if there's a problem with the model data. But so far, these panels have been very dependable. So first glance this morning, in fact, let me just bump this up to 18Z so we'll get the afternoon look. Alberta Clipper coming out of the Dakotas and Nebraska, so I'm going to put that front right there. And I can also see that there's probably a warm front somewhere in this area here. Now, we can't really use this precipitable water field because there could just simply be a lot of moisture out south of the warm front. So really what we need to do is look at the temperature fields, and let's do that. And as we see here, the big transition is down to the south. That's where we need to be looking for the warm front, somewhere down there. Now your eye might be drawn to this area or that boundary right there, but you do have to be on the warm side of any gradients. Let's just go straight to the observed data. Here we're looking at the Aviation Weather Center maps, and what I like to do is go to the warm sector, look at the air mass there. I see that it's predominantly 73 to 78 or so. There's a few 80s out there around Columbia. But I would say an average ballpark, yeah, it's about mid-70s with a 40-degree dew point. So we go north. By the time we get to Chicago, it's down to 63. 64 at Dubuque. That's quite a bit cooler. Let's also check out Indiana. Mid-70s right there around Evansville. Even some mid-70s around Indianapolis. And then we cool off up to the north. So this is telling me that there is likely a warm front somewhat like that. In fact, let me use the correct color. No, wait, that's 72, not 77. Yeah, I'm going to bias that a little bit further south because of that. There we go. And then the cold front, of course, running about like that. And likely we have an inclusion up to the north. So this is telling us that the triple point located right there, that's going to be around Cedar Rapids. And the warm sector located right there, and then the so-called area of overrunning up to the north in that region. So that's how we go through an analysis. So the front located right there, the warm front right around there. So that's what we're going to be looking for on our surface map. Any other fronts? Yeah, I see the tail end of that front in Nevada and Utah. This looks to me like maybe something like that. Maybe even a little bit further south because we got those northwest winds in the southern deserts of Nevada. Many years ago, I worked at the Tonopah Test Range right in that area. Whenever we had that northwest flow, that was always a sign that we have had frontal passage. And there you go. Northwest winds right there. It looks like the front is probably right in this region right here. And I think that kind of connects back up, something like that. And then we've got to consider the eastern U.S. Well, we do have a ridge and high pressure extending through this area. So the front may not necessarily go through that region, but if it does, I'm going to look for it somewhere right around there. So that's going to be around Washington, D.C., West Virginia, and up to Indianapolis. Now, another thing that you can really see here is the strong downslope flow in West Texas, bringing the temperatures up into the 90s. And a lot of that is due to the strong pressure falls in this region right here. And as a result, we get that flow coming in from Arizona, New Mexico, and Old Mexico. There's a look at that downslope flow in West Texas, and I would say that our dry line is starting to form up there. Now, the wind flow across that dry line is kind of unidirectional. Typically, we don't see intensification of that dew point gradient when the wind flow is like this. So, I don't think we're going to see too much this afternoon. Most likely, things will be dominated by this continued southward movement of the cold front. Now, what about storm potential? If you're a good forecaster, you're always going to be looking for that possibility, especially since we see the dew points coming up into the upper 50s in northern Oklahoma. So how much moisture do we have? Not a lot of it. Very little cloud showing here, just a little bit of cirrus up in western Kansas. Now, that doesn't completely rule out convection. You can still get a cumulus field going later in the afternoon and deep convection forming. So we need to look at the high resolution rapid refresh to see what's going on. So there's the high resolution rapid refresh, and you can see the moisture axis running from about Vernon, Texas, up through Altus and up to Enid. So I'm going to put a sounding right in the middle of that around Enid, and we'll see what that shows. So we can see the 59-degree dew point there at the surface, tapering to about 50 degrees at 3,000 feet and much drier air above. Now, when we get that mixing going during the afternoon, that's going to transport some of that dry air to the surface with those convective cells, and some of the low-level moisture will be transported aloft, and eventually you're going to kind of mix the column to something like that right there. So instead of having this green line in the lower levels, you have something like this blue line right there. And you can see that's not really enough moisture to support thunderstorms. Even if we could get thunderstorms going with this thin layer right here, if we construct a sounding with, say, a 90-degree temperature, that's going to give you your LCL right about there, and that's still a significant amount of negative area to overcome. So we can pretty much rule out the possibility of storms. And the other bit of writing on the wall is the low CAPE. Even the most optimistic CAPE values there are showing pretty much nothing. And then we'll want to kind of check around a couple more spots. That's down around Altus. Kind of looks like a similar deal down there. And also we have to take into account the effects of advection and look upstream. So right here around Graham, Texas, Throckmorton, the moisture is really not much better. So what you're seeing here is kind of how we analyze a convective situation. And it is important this time of year because we do get severe thunderstorm episodes in October and November, believe it or not. Even though the pattern is pretty much dead, in prior years, we've had some very active scenarios. There's our weather map for the southeastern U.S. I've put that dry line there from, looks like around Medicine Lodge, down to Quanah, Texas, and down to Bakersfield, Texas. So behind there, yeah, teens and 20s. Ahead of it, upper 50s, not particularly moist, but That is definitely a moisture flow coming northward. And then that front that we talked about from Virginia to Iowa and back towards Colorado. Not much to say about the satellite imagery. Looks pretty dry, and looks like Florida is starting to get its typical easterly flow. You can see that little sea breeze working inland around Jacksonville and Daytona Beach. In the northeastern U.S., we get into the weather systems proper. So that's about where we're at right now. The front's running roughly like that, and then the occlusion, of course, spiraling up into Montana. Still some cold air advection up in the Montreal, Quebec City, and northern New Hampshire area, but elsewhere looks pretty dry and kind of a nice day. There's the northeastern U.S., occluded system heading for the Great Lakes region. The warmest temperatures associated with that warm sector located right there in Iowa. And you can see that it's cooler on three sides. So this is the baroclinic zone, and most likely that's heading for Michigan or possibly northern Indiana. And I would expect the greatest potential for development to be in that region. There's our map for the northwestern U.S. This air up in Canada is fairly cold. Even at this hour, this is right around lunchtime in Calgary and Edmonton, and they're only in the mid-30s. So that's certainly a cold start to this Wednesday. A lot of the high pressure associated with that formed up into a ridge from Nebraska northwestward. This almost looks like a Pacific system, but I know that this is kind of a combination of Pacific air moving inland and also some continental Canadian air flowing right in there. So they're kind of working synergistically. And there's our satellite loop. This front moving through that area, not without some instability. So that's a sign of cold air aloft and likely the presence of some troughing in the upper levels. Looking at the upper air chart, well, not really any troughing, but there is some very heavy flattening of that ridge out west. And of course, the go-to chart ultimately is going to be the upper level temperatures. And there it is, 500 millibar temperatures showing some cold conditions aloft over Montana. And this pretty much forms up into an upper level front, maybe running something like that. And we can see that from North Platte, it's minus 10 Celsius at 500, but you get all the way up to Great Falls, and you're looking at about minus 27. So that's a difference in Fahrenheit from 14 all the way down to about minus 10 Fahrenheit. Quite a change there. And of course, if we drop a Skew-T on the Great Falls area, you're going to see some steep lapse rates. And there they are. That column is almost dry adiabatic. So certainly if you get any residual moisture in with that, you're going to get some cold convection. And finally, circling around to the southwestern U.S., there's the tail end of that front, and I kind of suspect it may be moving into the area north of Sacramento. I'm not 100% sure about it, and there is some adiabatic warming on the lee sides of those mountains up there. But the winds are out of the north, and it looks like there's a bit of drawing, so that could represent an air mass change. Plateau high across the Four Corners area, and then, of course, the usual heat low around Yuma. Satellite loop shows things pretty quiet in the southwestern U.S., but definitely some fast flow associated with that polar front jet. And I suspect as these pressure rises come in from the north, we should see the winds picking up in California. That's bad news for the fires, and I suspect there's been some emphasis on containing those before things get out of hand. I can see the smoke plume there in the Sequoia Park region. Looks like that's coming out of the north now. So that's showing a bit of a wind direction change. And then just looking at the winds in that fire area, Sierra Nevadas. Let's just take a quick look at that. That's where we're at today, and we can see right now, looking at the hodograph, that's really the best place to go for winds. We can see kind of a light northeast flow in the lower levels. By midnight, it looks like the winds have died down. Then by tomorrow afternoon, yeah, it's still light, so I guess we're not going to really have much in the way of problems. Yeah, this is good. Looks like that air mass is not going very far south. So we would probably see the hodograph shape something like that if we were getting into a heavy cold air advection pattern, but that's not the case, so that's good news for the fires. And that's all I have for this edition of Forecast Lab. I want to thank our new supporter, David Moore, for helping to keep this program going. As things are right now, I'm spread between many different projects. And unfortunately, I do have to focus on those that are bringing in income. And you all are helping me to achieve that with Forecast Lab. So thank you. And hopefully we can keep this program going for the indefinite future. All right, I hope you all have a great Wednesday evening, and we'll see you tomorrow for Thursday's edition. Thank you. Bye-bye.